Welcome to the deep dive. If you've spent any time writing Java code, you definitely know the routine.
Oh, yeah.
Create a class, add the fields, then you grind out the constructors, getters, equals, hash
It's just
codes.
by hand or you hit that IDE shortcut.
Exactly. It's boilerplate, just plain and simple.
Yep.
So today we're cutting through all that noise. We want to understand a really powerful feature that's designed to fix this exact problem, Java records.
Mm-hmm.
It feels like a game changer for how we handle data. Okay, let's unpack this.
Yeah, and what's truly fascinating here is just how elegant the solution is for such a common, everyday programming need.
Right.
They really are a
Yeah.
big step towards, more concise code, more robust code, too.
And readable.
And readable, definitely. So our mission, basically, for this deep dive is to give you a clear, practical understanding of Java records.
Okay.
What they are, how they work inside, and maybe most importantly, when you should actually use them.
All right, let's get straight into it then. What are records in Java? I know they came in officially, standard feature, Java 16.
That's right, Java 16, JEP 395 for those keeping score. It was previewed before that in 14 and 15, getting feedback.
Okay, so it's been refined a bit.
Exactly. And you can think of a record as a highly specialized, very compact kind of class.
Purpose-built for data.
Purpose-built for carrying immutable data. That's key. The whole idea is to slash that boilerplate we were complaining about.
Right.
It's almost like Java saying, look, here's a smart little data capsule. You just tell me what data goes inside. I'll handle the messy bits.
Okay. So the messy bits are the problem they solve.
Precisely. The core problem is just the sheer amount of repetitive code you used to need for classes that, honestly, their main job is just holding data.
Like a person, class, name, and age.
Perfect example. Before records, you're writing out the constructor, the getters, equals, hash code, toString,
The whole ceremony.
the whole ceremony. With records, Java just gives you these
Yeah.
automatically.
Which one's specific?
You get a compact constructor, public accessor methods for each piece of data, each component, and solid implementations for equals, hash code, and toString,
And the compiler does this.
all handled by the compiler.
Yeah.
Consistently, correctly.
Wow. Okay, that does sound like a huge simplification. Gets rid of a lot of tedious, maybe error-prone work.
Absolutely.
So could you walk us through those features again? Like, what do they actually mean in practice?
Yeah, definitely. The beauty is in these inherent characteristics. First, big one, immutability by design.
Meaning you can't change them once they're created.
Exactly. Once a record object exists, its state is fixed. This isn't just fewer bugs. It fundamentally makes reasoning about shared data easier.
Especially with threads, right? Concurrency.
Huge for concurrency. Makes things much more predictable. Second, this component-based structure.
Okay.
So whatever data pieces you declare for the record, those are its components. Each one becomes a private final field.
Private and final. Got it.
And the compiler generates a public accessor method for each. So you have a name component, you get a name method. No get prefix.
Just name. Cleaner.
Yep. And third, as we said, the auto-generated utility methods equals hash code, toString, based on all the components.
So they compare correctly, hash correctly, print nicely.
All out of the box. This is where, Java records really start to shine.
Okay, so connecting these design choices, why should developers really care? I mean, beyond just typing less, what are the deeper implications here?
Well, it's quite a significant shift. They fundamentally simplify data classes. Think DTOs, data transfer objects.
Right, passing data between layers.
Exactly. Or entities and APIs. Records are perfect for that.
Hmm.
And their built-in immutability, as we discussed, makes data inherently safer to share.
Across threads or just different parts of an application.
Both. It seriously eases the burden of managing concurrency. And by reducing boilerplate, you're not just saving keystrokes. No, you're making the code clearer. Developers can focus more, deliver faster, with fewer accidental bugs from complex, hand-rolled methods.
That makes sense. Cleaner code is easier to maintain.
Definitely. Which leads to standardized data representation. It improves readability, maintainability, especially in big projects.
So concrete use cases, database results, API responses.
Absolutely. Database records, API responses, configuration objects, even simple values passed around in, say, a stream pipeline.
Okay.
Basically, anywhere you need a simple, reliable, immutable container for data. That's the sweet spot.
Gotcha. That brings us perfectly to the explicit advantages. What are the big wins developers actually see?
Well, the obvious one is that concise syntax. A record with several fields, often just one line.
Compared to dozens before.
Exactly. But the advantages go deeper. Immutability by default, we keep coming back to it because it's huge. It cuts down so many bugs from unexpected state changes.
And makes them thread safe, you said.
Naturally thread safe.
Yeah.
Critical for modern concurrent apps. It simplifies really complex synchronization problems.
Okay, what else?
The automatic method implementation equals hash code, top of string. It's not just convenient, it guarantees consistent correct behavior.
Which can be tricky to get right manually.
Oh, notoriously tricky. Subtle bugs love hiding in custom equals and hash code. Records avoid that. This consistency, plus the compact form, means improved readability.
You see a record definition, you know its job.
Pretty much. It screams, I just carry data.
Yeah.
They also have excellent framework compatibility. Modern frameworks like Spring, Jackson, they handle records really well now.
For things like JSON serialization, or as DTOs in Spring.
Yep, exactly. And of course, there's still Java classes, so you get a full type safety.
Okay, it sounds like a lot of good stuff happens automatically. Almost for free. But what's the internal cost? How do they actually work? Is it complicated under the hood?
That's a really good question. Understanding the mechanics helps demystify them. They're not some exotic new runtime thing.
Yeah.
No, they compile down to regular Java class. It's just a specialized form. Internally, a record becomes a final class.
Final, so you can't extend it.
Correct. And it implicitly extends java.line record. So it can't extend other classes either. But importantly, it can implement interfaces.
Ah, okay. So you can add behavior through interfaces.
Exactly. Now, for component handling, each component, like name or age, becomes a private final field.
Got it.
And the compiler generates that public accessor, like recordInstance.price, for a price component.
Simple.
Very. They also get that automatically generated canonical constructor. Takes all the components as parameters, initializes the fields. Straightforward.
And the immutability, how's that enforced?
The compiler makes sure all those fields are final. Period.
Yeah.
No setters are generated. It's locked down after creation.
Okay.
And the key thing here is this isn't runtime magic. At compile time, the Java compiler translates the record source code into standard class bytecode.
So no performance hit at runtime?
Virtually none compared to a well-written manual immutable class.
Yeah.
It's just compile time generation. They fully support reflection, serialization too.
So you can think of them like a template.
That's a great way to put it. A template. You define the data field, Java fills in the constructor, accessors equals, hash code to string. Guarantees consistency, guarantees immutability.
That is a clever design. Really efficient. But, nothing's perfect for every single job, right?
Sure.
So records are great, but where do the, let's say, problems or maybe the trade-offs and limitations show up?
Yeah, trade-offs is probably a better word. While immutability is a huge plus, it's also the main immutability restriction. If your class needs mutable state,
Then records are out.
then records are just not the right tool. Stick with a traditional class. Other things to consider. Their limited flexibility.
Because they're final and extend java.lang.
Exactly.
Yeah.
Can't extend other classes, can't be subclass. So complex inheritance hierarchies, not going to work with records.
Okay.
This also means no custom setters. We talked about immutability. If you need to change a record's value, you actually create a new record instance with the updated values.
Right, the copy and update
Yeah.
pattern.
Precisely. And while you can write custom constructors, any custom one has to eventually call the main canonical constructor.
To make sure all fields get initialized.
Right, which can sometimes constrain really complex setup logic. There can also be a bit of a conceptual shift for developers used to mutable Java beans.
Thinking immutably takes practice.
It does. And you might hit framework compatibility issues, though less often now. Older frameworks might need workarounds for serialization or reflection, maybe special annotations.
Like Jackson's at JSON Creator.
Exactly, that kind of thing. Check the docs. And finally, if a class needs significant behavior beyond data, complex business logic, lots of methods that do things.
Records aren't the best fit.
Probably not. They're designed for carrying data, not complex operations, which raises an important question.
Which is?
How do developers, especially maybe beginners to this feature, best navigate these nuances? How do you use records effectively?
Right, that's exactly what we need to cover next. What are the key things developers should know to really leverage records well?
Okay, so number one, understand their purpose. They're for data carriers. DTOs, database results, config objects, simple, immutable data buckets.
Don't try to shoehorn complex logic into them.
Please don't. Second, embrace immutability. Really internalize that changing data means creating a new instance. It's a different way of thinking, but powerful.
Okay, what else?
Third, trust the auto-generated methods. Rely on the built-in equals, hash code to string.
Mm-hmm.
They're good, they're consistent. Don't override unless you have a very specific reason.
Makes sense. Less code to maintain.
Fourth, combine with interfaces. Remember, they can implement interfaces. This is how you add specific behaviors if needed, like making them comparable for sorting.
Ah, useful.
Fifth, verify framework compatibility. If you're using Jackson, Spring, whatever, just double-check their docs for any specific setup needed for records. Usually just works, but good to check.
Couldn't practice.
Sixth, start small. Just try it out. Make a simple point record with X and Y. Get a feel for the syntax, see the benefits firsthand.
Experimentation is key.
Always. Seventh, know when to use traditional classes. If you genuinely need inheritance, mutable state, or lots of complex logic tied to the data, a regular class is still the way to go.
Use the right tool for the job.
Exactly. Yeah. And finally, prioritize readability.
Yeah.
Since records are so concise, make those component names really clear and self-explanatory. They carry more weight.
That's a fantastic set of practical tips.
Right.
So maybe to sum it all up for you listening,
Yeah.
records in Java are this really powerful modern feature. They're built for creating concise, immutable classes that just carry data.
Right.
They slash boilerplate, they improve clarity, and you get that thread-safe immutability baked right in. Ideal for a lot of modern Java stuff, especially DTOs or simple values.
Yeah.
But yeah, their main strength, immutability, and that limited flexibility mean they aren't a silver bullet. They don't fit every single situation.
It's about understanding where they shine.
Exactly. Knowing when and where to apply them in your designs.
And maybe a final thought to leave you with. Considering how popular records are becoming and their very specific design, how might their widespread use start influencing broader design patterns, especially for handling data in Java?
Oh, interesting.
Will we see an even stronger push towards immutable structures everywhere, particularly as our applications get more distributed, more concurrent?
That's a really good question to ponder. How this focus on immutable data carriers might reshape things down the line.
Yeah, something to think about as you start using them more.
Definitely. An excellent thought to leave you with. Keep exploring, keep learning, and keep diving deep into Java.